Hello everyone and welcome back to the Kohi Game Engine series. Today we're going to implement our material system. I would like to take a quick second and thank the supporters of the channel, beginning with our partners, Eearslya, Wensheng, and Caden. They are the partners of the channel, which is the highest tier of support for the channel, so thank you very much for that. And I would also like to thank all the other supporters listed here on the screen. Your support is very much appreciated, so thank you for that. So last time we laid down a lot of prep work. We created a hash table that we used for our texture system that we're again going to use for our material system. We created the texture system. We made some changes to the architecture and the way that texture data gets passed around. And today we're actually going to go ahead and make some additional changes to support our new material system. And our material system is going to be able to be loaded a couple of ways. So there's going to be a manual way of doing it in code, where you can create a material in code. And we're also going to support loading from a basic file format. So with all that said, there are a couple more things that we're going to need in place in order to stand up our material system. So we're going to kind of hop around a little bit and do a little bit more prep work, although it's not going to be as much as last time. Okay? So one of the first things that we need to do is we need to, again, add some functionality to our strings. So right now, we basically have some pretty basic and straightforward string methods, and we need to add a couple things to this. We need to add not only a couple of copy methods, but some other methods like being able to trim a string, or to be able to take a substring of a string. Also the ability to get the index of a particular character in a string, as well as be able to parse some various types of data from a string to that type of data. So what I'm going to do is I'm going to sort of jump around section by section and just plop these in here a couple at a time. So the first one that we have is a string copy. And what this does is it takes the content in source and copies it to destination, also returning that destination. And then we have a string encopy, which does basically the same thing, but with a maximum length of the length that is passed in. Okay, so we're going to need both of those things. Okay, as I alluded to before, we are going to need a way to trim strings, so that is to trim the white space off of both ends of the string. And then we are going to need a way to get a substring, and we're going to do that called with a method called mid. So all that's going to do is, again, take a destination pointer. It's going to take a source, and it is going to start somewhere in the string and potentially get a substring of the provided length, or to the end of the string. However, this is going to support one more thing that we'll get into in a little bit, where we can pass -1 here to say go to the end of the string no matter what. Okay, so that's that. The next thing that we'll need is an index of method, and all this does is takes a string and a character and returns the index of the first occurrence of character C. If character C does not exist in the string, it returns -1. All right, so with that, we also want to include the ability to parse some of our various math types. Specifically, our vector types. We want to be able to parse those from a string. So we're going to need an include for our math types. And then down here at the bottom, we are going to create a few methods. So we have string to vector 4, which returns a boolean true or false, indicating success of the parse. So what this does is it takes in a string and a pointer to a vector 4, and it attempts to extract 4 values out of the string into the vector 4, into the x, y, z, and w respectively. Okay, So the string that is passed in should be space delimited. That's going to be the case with all of these. Okay, and so it should look something like this, where you have, say, the first value, space, second value, space, third value, space, fourth value. Okay. If you have commas or any other character in here, it will stop parsing at that point and only return what it was able to successfully parse thus far. Okay. The other thing that it does is it zeroes out this memory actually before it sets anything. So it sets all the elements to 0 and then only replaces what it could actually parse. So if it's only if you're trying to parse a vector 4 out of it, but you only provide, say, the first 3 vectors, the last one will automatically be 0. Okay. Works the same way for our string to vector 3, only with 3 elements, and our string to vector 2 with 2 elements. Okay, pretty self-explanatory stuff, I think. So the next thing that we want to be able to parse is float values from string. So we have one for float 32s and one for float 64s with a respective pointer to each. And then the next is coverage of all of our integer types, and there are 8 of them, as you might recall, because there are 4 sizes of string. So we have 8, 16, 32, and 64, signed, which is these 4, and unsigned, which is these 4. Okay? And then finally here at the bottom, we have a string to Boolean. And the way that this works is the string that is passed in either needs to be equal to 1 or true, and it is case insensitive, but it needs to be true. Anything else will not be considered true. So the way that this is going to work is true or 1 are considered true, everything else is considered false. Okay, and that is the collection of functions we need to implement. Okay, it sounds like a lot, but actually these functions are pretty straightforward. So the first thing that we're going to need is in our kstring.c at the top, we are going to need to add one more include to ctype.h. And this is for a method called isSpace that we're going to use in our trimming, right? And this is just to detect if a character is a space, right? So we're going to need that. And we'll start off with the string copy and string end copy. These are pretty straightforward. They just use the standard library functions for now. We may wind up implementing our own version of this at some point, but for now, these are fine. Okay. So all this does is copy. All this does is call string copy and string end copy, respectively. Okay. Trim is not quite as simple, but still not too complicated. So the way that this works is it first begins looping through the string, looking at each individual character of the string and asking if it's a space. If it is not, then it goes ahead and moves the pointer forward 1, which is essentially moving on to the next character of the string. Okay? And so this just basically keeps going until it finds a non-space character. So once we've completed this loop, if we have a non-zero value in the current character of string, we go ahead and create a character pointer, right? So we're basically creating a copy of this pointer at that point. And we begin looping through it again. So all we do here is we say while we have a non-zero character, we move forward, right? And this basically takes us to the end of the string, right? So we start at the point we left off here, and then we proceed to the end of the string, which would be a 0 termination, okay? Once we do that, we begin a backwards loop from the end of the string, checking the same thing that we checked up here, only against p, right? And so what we do is we dereference p, and we say, okay, is that character a space? Of course, decrementing that afterwards. So basically we back the p pointer up to a non-space character. And then we say, okay, the character after where p stops, searching backwards, we are going to set that to 0. So in other words, we're going to terminate this string there. And so what this effectively does is changes our string pointer to begin at the first non-white space character, and changes the end of the string to just be 0 terminated after the last space, right? So from there, we go ahead and return. Okay. So mid, this is the substring method. So first off, if length is 0, we're going to go ahead and boot out because there's nothing we can do there, right? If not, we go ahead and we take the length of the source string, right? And we say if the start is greater than the length of the source string, then we go ahead and just terminate the destination at the first character, meaning we have an empty string. Because if the start of the substring is after the end of the string, we have no substring, right? We just return an empty string. So that's what that does. Okay, so here if length is greater than 0, right? So we've already checked it for 0 here. So if length is greater than 0, then we go ahead and we loop through the string until we hit length, right? And then we also double check to make sure that each character is non-zero, meaning we haven't hit the end of the string, right? So as long as we are not at the end of the string and we have not exceeded length, then we're going to continue moving on. And what this does is copy each character along the way, okay? So as long as we haven't hit the length and as long as we haven't hit the end of the string, we keep copying. Once we have reached the end, right, we've reached length or we've reached the end of the string, we go ahead and terminate the next character in the destination by looking at the start plus the length, and we set that to 0, okay? Now, if length is not greater than 0, and also not 0 because it would have hit here, then that means it's negative. And if a negative value is passed, then that means that we want to basically disregard any length here and just proceed to the end of the string. So instead of checking to see if we have surpassed a length, all we do is we check to see if the source character, current source character, is 0. So if the current character is not 0, we go ahead and copy it. Otherwise, we break out of the loop and we set destination start plus j, so wherever we wound up in the string, equal to 0, which effectively terminates it. Okay. All right. So index of is pretty straightforward too. So first off, if we don't pass a string, we return -1, right? Because that's rubbish. There's nothing we can do with it. Next, we take the length of the string. We say if the length of the string is greater than 0, then we go ahead and process it. However, if it's a 0 length string, it's just going to return -1 because you can't search an empty string. Loop through the string, look at each character to see if it's equal to C. If it is, you return that index. If you go through the entire string and never find it, you return -1. Okay? All right, so now our parsing methods, starting with string to vector4. So first off, if we don't have a string, we return false, okay? Next, if we do have a string, we go ahead and we zero the memory out of the vector, right? Size of vector4. And then we take the result of a scanf operation, which scans the given string here using this format and outputs to the various pointers that we have here, right? So we have the address of x, the address of y, the address of z, and the address of w. And our format string says that we're looking for 4 floats, space delimited, okay? And that's these spaces here, okay? The result will return the number of elements extracted if successful. If it fails for any reason whatsoever, trying to extract this data, and it can't extract any data whatsoever, result will actually be -1. So we return as a result if our result is not equal to -1, meaning success, okay? So success in this case might not necessarily mean that we get all 4 elements, but it means at least 1 element has been extracted, okay? So string to vector3 and string to vector2 are exactly the same. They just have 1 less element and 2 less elements respectively, so I'm not going to go over those. And then our string to f32, again, looks to see if the string exists, returns false if not, starts by zeroing out our pointer to our float, and then goes ahead and again uses scanf with a single floating point as the string, okay? And again, if it's able to extract data, then it will return something other than -1. If it is not able to extract data, it will return -1. And then our success is determined by that, okay? So we have F32, and then we have F64, which is our 64. The only difference between these two functions is this looks for %f, which is the token for float. This is using LF, which is a long float, which is a 64-bit float, okay? So next, I'm actually going to skip ahead a couple of methods and go straight to string to I32. So this takes a pointer to I32, does the same check. This is pretty much the same function as this guy up here. The only thing is it uses %i instead of %f to extract a 32-bit integer. Pretty standard stuff. I16, which goes right above it, is exactly the same, except with different types here, of course. The only real difference is we use %hi, which is basically saying a half int, right? So it's telling scanf that we only have room to hold a 16-bit integer and to only extract that, okay? Likewise, with I8, which again goes above that, we switch the type, and then we use HHI, which is basically half of a half int, is the way that I remember that. And otherwise, it's exactly the same, right? So that is the way those work. So if we go ahead and skip down below I32, now we have I64, which uses a long integer, right? So this is telling it how big that should be. And then all of the unsigned versions of these look exactly the same. Instead of %i, they use %u variants. Otherwise, they're exactly the same. So I'm not going to go over those individually, okay? As you can see, once you explain one, the others pretty much fall in line. The last one I will go over is string to bool, which again does our check. And this literally just does a strings equal check against 1, right? So if 1 is passed literally as the string, it will mark that as true. Otherwise, it does a case insensitive check against true. So you could technically pass true or, you know, something awful like that, and it would still work, right? As long as the text is true and it matches this in a case insensitive manner, then it will return true. So that is what that does. And that is it for our string, okay? So pretty straightforward stuff, but necessary all the same. We're not going to use all these right away, but I figured it makes sense to just go ahead and get them implemented. So next we're going to take a quick look at file system, because there is one method in here that really needs to be addressed, and that is file system readline. So the way that this currently works is reads up to a new line or end of file, right? However, this allocates line buff, which must be freed by the caller. This is crap, right? We're gonna do away with this and do something better. So what we're gonna do is we're going to let the caller be responsible for any allocations or deallocations, and simply take a pointer, right? So I'm actually going to replace this entire function with this one, okay? And this takes in a file handle. It takes in the maximum length that the line can be, right? So you can cut it off at some point. It takes a pointer to a character array, which is our line buffer, right? And then it takes a pointer to the outline length, letting us know how long that line is, okay? So in the file system.c, we are going to go ahead and swap out how this works as well. However, there is one small thing that I want to address before we do that. You'll note here that we get an error for this stat buffer because it's saying that the incomplete type is not allowed. Technically speaking, GCC supports this, but we've not actually really used this all that much, and that's why we haven't really hit an error with it. So this is what's implemented on Linux, right? And really what we need is the Windows version of this too, which unfortunately is different. So what we're going to do is we are going to wrap this in some if-def checks to get around it, okay? And so what this is doing is to say basically if we're using Visual Studio, we're going to use the underscore stat structure and method, right? Why they decided to do it this way, I don't understand, but this is Windows' way of maintaining compatibility to be able to port Linux code to Windows. So these are the versions we have to use for Windows, otherwise we use these, okay? Ultimately, it doesn't really matter outside of this function how this works, so we can go ahead and plug this in and it'll be safe to use. All right. Now, back to our file system read line. We're basically going to clobber this whole thing and replace it with something that's actually simpler, okay? So here is the new version of that. So what this does is it checks to see if there is a handle. It checks to see that line buffer isn't a null pointer. It makes sure that the out line length is actually has an address. And it also makes sure that the max length is greater than 0, right? Because if max length is 0, what are you really doing? You're reading nothing. Okay, so if any of those fail, it returns false. So what we do here is we grab a character array, right, by dereferencing line buff, right? So that is that. And then we pass that to fgets, passing the max length that we passed here, our file handle, and then we say if fgets does not return 0, aka a null pointer, then we go ahead and dereference and set our out length, line length, to the string length of the dereferenced line buffer, right? Which will work because these two pieces of memory are the same thing, right? So we do that, and then we return true, and that gives us our line read in from a file, okay? So a simple modification there, but one that was necessary all the same. So the next thing we want to do is, within our resources, our resource types, we need to add a few types of resources here, okay? But first, I want to actually enhance our texture a little bit, right? So before we actually move on to materials, I want to add a couple more things for convenience to our texture, right? And the first thing I want to define is the max length of a texture name, which we're going to say is 512, right? There's not really any reason to even have a name that long, but if you do want to name that long, we'll support it, okay? And then right above internal data, we're actually going to create a character called a character array called name, rather, of that length, okay? And this is just going to allow us to always have that sort of allocated without worrying about dynamic allocation, right? And we might wind up cutting that in half just to save on some memory, but for now we'll go with 512, okay? The next thing that we want to do is something that I put a to-do note on before, which is indicate a texture use, right? Because we're going to have lots of different uses for textures. And the first one that we want is a texture use map diffuse, meaning this is used, the texture that has this will be used as a diffuse map, right? There's also unknown, which is 0, the default, right? So we have our texture use enumeration here that we will wind up expanding over time. So next, there's actually a couple changes that I want to make to our texture system. And these are relatively small changes, but ones that I believe are necessary regardless. So under systems, texture system.c, we want to go to the top here and forward declare a method called destroy texture. So that way we can destroy all textures the same way. It just takes a pointer to a texture, okay? And we're going to go all the way to the bottom of the file and define that. And all this is going to do is it's first going to call render destroy texture, passing along the texture to clean up any backend resources. It will go ahead and zero out the memory of name, which we just added, right? So anytime we destroy a texture, we want to zero that out. We're going to zero the texture itself, which technically this is redundant, right? Because it technically would be included in this. But it's just sort of being explicit as to what we're doing. We'll set the ID to invalid ID and the generation to invalid ID, okay? So the next thing we're going to do is we're actually going to make some changes to the texture system release. So one of the things that happens is when we actually destroy the texture, when we call destroy texture, this character array here will more often than not be just the texture name passed over to us, right? So when we actually clobber the texture itself, we'll be clobbering the memory that this points to. Therefore, we won't be able to use the name down here for some of these things. So what we're going to do is right after we check to make sure that the thing is actually going to be clobbered, we're going to take a copy of the name, since it will be wiped out by destroy, right? And we're going to just store that in a local character array called name copy, okay? And then what we're going to do is within here, instead of calling render or destroy texture and zeroing in its memory and all this other stuff, right? We're going to remove these lines and we're just going to call destroy texture, right? So we destroy / reset the texture, okay? The next thing that we're going to do is we're going to take anything that is made, any call that is made after this, and change name to name copy. Okay, so that should be that one and that one, right? Because that actually, in order to actually update this, we actually need the name copy. This is where it's actually critical, right? These are just logs. They'll technically just log an empty string. This here is critical to get right? If we don't have a name copy, we actually can't update the hash table because we no longer have the string. So we have to use the name copy on that, okay? All right, so that is it, at least as far as our release. The next thing that we're going to need to do is in our create default textures, we're actually going to handle this texture creation a little bit differently. So instead of render or create texture, taking in a texture name and all these dimensions and all this other stuff, we're actually going to simplify this interface, right? But before we do that, we need to make sure that we go ahead and set those things here, right? Because it's really the texture system is what should be doing that, not the renderer, right? So what we're going to do is we're going to copy the texture default texture name into the texture.name. We're going to set the texture width, height, channel count, generation, and has transparency. We're going to default to false, right? And in this case, it's false because we know we don't have any alpha data here. And then we're going to go ahead and call render or create texture, okay? And what we're going to do as far as render or create texture goes is we're actually going to change that interface as well as the interface all the way down to only accept a few of these properties. So I'm going to come back to that change here in a second. I just want to finish up making the changes here, okay? So in the destroy default textures, we're just calling render or destroy texture, and then we're sending the default texture. We actually need this to be destroy texture now, so that it properly destroys everything having to do with that. And then one quick bug that we need to fix is if we ever have a failure reason, it is not actually cleared whenever you call this, right? We actually call it twice here. And so if we ever do wind up with an error here, we're always going to wind up erroring from then on forward, right? So what we need to do is if we do have an error, we're going to bleat about it, but then we're going to clear the error so the next load attempt doesn't fail. And we do that by just calling this stbi__error. And we basically just pass zeros for both of those things, and that clears the error internally. Not the greatest interface to do that, but it's what's there, so it's what we got to do. So the other place that we want to set this is down here, right, in our else condition. So we'll go ahead and set that there as well. And then I don't want to forget up here, after this check, but before render or create texture, we actually want to take a copy of the name, right? So we're going to take a copy of the texture name that is passed in and store it in the texture.name. We're also going to set the generation to invalid ID and has transparency to the passed in has transparency from the STBI load, right? And so again, we're setting these things here because the renderer should not be responsible for doing that in this call. With that said, let's go ahead and change render or create texture. renderer front end. And basically what we're going to do is we're going to get rid of name, width, height, and channel count, because those things are all actually included in the texture itself. We're going to keep pixels, we're going to get rid of has transparency, and we're going to keep out texture, except we're just going to rename this to texture, right? Because it's not really outputting a texture anymore. It's taking in a structure that's already been created. Okay, so this is much simpler to call now. We just pass it pixels and a pointer to the texture. Okay, so in the renderer front end .c, we're actually going to replace this as well. All right, and now it's just that. But that means that the back end needs to be changed as well. So we're going to go to renderer types, and we're going to take create texture, and again we're going to snip out the same parameters, and we're just going to take pixels and texture, right? Again, we're not going to call that out texture. Okay, so now that's much simpler as well. Then we'll go into our Vulkan backend, and when we create a texture here, we're going to do the same thing, right? So we're going to snip those out, snip out has transparency, and only take these two. Again, we'll rename this to texture. Okay, and that means we have to go into the C file and Vulkan renderer create texture, snip all of these out, and snip out has transparency, and we'll just call this texture, right? And so actually, yeah, that's fine. So we're going to rename this to texture, right? And actually these things go away, right? Because those are set outside now, so we don't need to set those there. We'll rename this to texture. And instead of using just the width, height, and channel count, we can get those from the texture now. Okay, this should just be texture. All right, let's go ahead, keep going here. So we need texture width and texture height to pass to Vulkan image create. And then a little bit further down, this has transparency is actually set outside as well. However, we do want to increment the generation, so we are going to leave that piece of code intact. Okay. All right. Okay, so that is all we need to do for that. That means we need to go back to the, let's see, renderer front end, and we need to snip out all these from the call. So we just have pixels and has transparency, and, or rather I should say, so we just have pixels and texture, okay? Which means obviously we need to go back to our texture system, and we need to get rid of these properties, and we just pass data and temp texture. Okay, and we have one more place we have to do that, which is here, right? So we're setting all these things here. We no longer need to pass them to render or create texture, and so we're not passing duplicate data around everywhere. We're not potentially passing the wrong things in one place versus another. This just makes the whole thing a little bit cleaner. Okay. All right, so I believe that is everything for the texture system that we need to do to actually support this. So now we can finally move on to creating our material system, okay? And I think the best place to start for that, you know what, there actually is one more change I want to make. So if we go back to Vulkan types INL, there are a couple things that I actually forgot to rename here. So we have some of these defines here that are still referencing the object shader. And so what I'm going to do is I'm going to do a find and replace all across all the files and just replace all instances. Okay. So I'll do that for material object shader stage count to material shader stage count. I'm going to take Vulkan object shader descriptor count, and I'm going to find and replace that to Vulkan material shader descriptor count. We'll replace all that. Okay. And then one more thing I'm going to do is I'm actually going to define one more thing, which is Vulkan material shader sampler count. This is how many samplers we actually have in the shader. So we're going to switch a few places that are using that. Okay. Let's see. We have Vulkan object max object count, which is again kind of a crappy name. So we're going to switch that to Vulkan max material count. Okay. All right, and then of course we have this struct here, which is Vulkan object shader object state. And this guy, I'm actually going to use F2 to rename. So this is going to be what we're going to call Vulkan material shader instance state. Okay, and this is basically just going to be referring to material instances, right? So I feel like that makes a little bit more sense than talking about objects everywhere, right? All right, so one more thing that I want to do is set up I want to use our new Vulkan material shader sampler count. Right after our buffer index, we're going to create an array of texture uses that is of the size of Vulkan material shader sampler count, right? And so these are basically going to hold texture uses for the given sampler index, right? And so that all that'll line up. Okay. This we renamed to material shader instance state, but we still call it object states. So I'm going to rename this to instance states. Okay. And I'm going to save all. Okay, so that should do it for the renaming for now, okay? So just want to get those things out of the way. Great. So let's go ahead and create our material resource, okay? So under resource types, we have our texture use. Now we actually need a material, right? And so we're going to type def a structure called material. Okay, and one of the things that we're going to need, just like textures, is we're going to need a name, and this we're actually going to set to 256, right? So we're going to have another macro here that defines material name max length. We're going to set that to 256, and then we're going to go ahead and insert some properties into the material, and this hopefully will give you guys a little bit of an idea of how this is going to be used. So we have an ID for the material itself. We have a generation for the material, much like we have for textures, right? So anytime our material changes in a drastic way, we can update that generation. We have an internal ID, which is a ID handle to our internal material data. And you'll see how that hooks up here shortly. We actually have a lot of the groundwork in place for that already. We have our material name. We have first our diffuse color, and then we have something here called a texture map, which is our diffuse map. And we haven't actually created a structure for texture map yet. So right above our material name max length, we're going to type def a new structure called texture map. And it's really straightforward for now. We're going to be enhancing this, but all it contains for right now is a pointer to a texture, and then it gives us a texture use, okay? And so we'll have one of these maps for each type of map that we have, okay? Right now we only have one. We will be expanding this. So that is it as far as resource types go for our materials. So now we can go into our systems and we can create a new file, and we're going to call it materialsystem.h. Okay. And materialsystem.h is actually going to look shockingly similar to our texture system. So I'm actually not going to walk through every bit of code on this because a lot of it is very, very similar to how textures actually work, okay? And so we define a couple of things here. We include our resource types, our defines, of course, and then we also give a default material name, right? Next, we have a structure for our material system config. All that does is take a max material account. So the next thing that we have is something called material config, not to be confused with material system config. So this is For the system, this is for an individual material. And a material config is something that's generally loaded from a file, but you can create in code. It has the name of the material, whether or not the material should be auto-released when there are no references to it, the diffuse color, and then the name of the diffuse map name, which ultimately becomes the texture name that we'll use to load the texture for the diffuse map. Okay? So this is a configuration struct that we will ultimately be loading from file. So as you might expect, we have an initialize and shutdown for our material system, memory requirement, state, and config. Pretty self-explanatory, so I'm not going to go over that any further. We have a acquire. This again is acquire by name. And then of course we have a release. However, this acquire is basically going to assume that we have a material file with that name and load it up. If we want to create a material in code, we have to treat that a little bit differently and manually create this config instead of loading it from a file. So we need another method which returns a material pointer called material system acquire from config. And this is one that we can set up in code and then it'll just load it that way. Okay? So we need both of those. And that is it as far as the interface for materials goes. Okay? So next we need another new file. We'll call that materialsystem.c. And as I'm sure you have surmised by this point, we are going to include our material system, our logger, our string library, our hash table, our math types, because we're going to need those, our renderer front end, and our texture system upon which this relies. We are also temporarily going to need our platform file system, right? Because we're going to be loading a file directly in here. And so what this means is that we do still have a to-do here for the resource system. We are going to be eventually putting a resource system in, and then we won't need this here. We can just call it resource system. But until we have that, this is what we need to do. So next we'll go ahead and create the material system state, which looks very similar again to textures, right? So it saves a copy of the config, has a default material, has an array of registered materials, and has a hash table to handle those material lookups by name. Okay, so again, pretty straightforward stuff. Also similar to the texture system, we have a reference, material reference in this case. It's got a reference count, a handle, which is the index into this array, and then an auto-release boolean. Of course, we have our static system state. And we're going to for declare some private functions here. And this, again, looks very similar to what we have going on in the texture system. So we have a create default material, a load material, which takes a material config and a pointer to a material, destroy material, which just takes a pointer to the material, and then we have a load configuration file, which takes a file path and spits out a material config. So basically, the way that this works is whenever we call material system acquire, what that does is it calls load configuration file, gets this config, and then loads the material based on that config. Okay? Great. So our material system initialize, I'm actually going to, again, put this in here as one big chunk because, again, we've seen most of what is going on here. So we basically make sure our max material count is above 0. If it's not, we bleed and return. Here is all of our memory requirements and to get our full memory requirement, okay, for our state, material array, and material reference hash table. We go ahead and say if this has not been provided, we're only calculating our memory requirement, we boot out and say true. Otherwise, we set our state pointer, we set up our array block, our hash table block, set up our hash table. Go ahead and fill the hash table with invalid references, just like we did in the texture library. We invalidate all materials in the array, so we set the ID, generation, and internal ID for each individual register material to invalid ID. And then we go ahead and we create our default material. If for some reason that fails to create, we bleat about it and return false. Otherwise, we return true. Okay? Material system shutdown. very straightforward as well. We cold cast the state to a state pointer. We say if that is not null pointer, then we go ahead and invalidate all the materials in the array by calling destroy material, which we'll hook up here in a minute. Then we go ahead and destroy the default material, set the state pointer to 0, and we're done. Material system acquire. Pretty straightforward stuff as well. So we basically create a temporary config. We create a format string with a pre-located path, right? So again, once we have a resource system, we won't need this, but for now we do. So we take our full file path, which is sort of our output buffer. We use this format string and we put name here and format there. The format for our material files is KMT, okay? And then we call load configuration file, passing the path and a pointer to that configuration here. If that fails, we bleat about it and return a null pointer. Otherwise, we call material system acquire from config, okay? And so we're able to pipe all this through the same logic either way, okay? Acquire from config is a little bit more complicated, but not too much. Again, it's mostly the same stuff that we saw in the texture library. So again, if we are trying to acquire the default material, we just return it in this case. So we go ahead and create a reference, check to see if we have a state pointer, make sure that we can actually get a reference from the hash table. If the reference count is 0, we go ahead and set auto release. So this works the same as textures. We can only set it the first time. Increment the reference count. If our reference handle is invalid ID, meaning that no material exists, then we need to find a free index in the array. So we go ahead and do that here. We loop through the entire array looking for an ID that is invalid ID. We go ahead and save that off as the handle, store a pointer to the material, and then break. We make sure that the empty slot was actually found, right? So that we make sure that that is not still 0 and that the ref handle is actually set. We create a new material by calling load material, right? If we fail, we bleat about it and return a null pointer. If the material generation was invalid ID, then we go ahead and set it to 0, otherwise we increment it. Then we go ahead and update the material ID to be the same as the reference handle, and then we put a trace message out to say what the ref count is. If the material did exist, we go ahead and say, hey, this already exists, we just bumped up the ref count. Then we update the entry in the hash table and return a pointer to the appropriate material. If all this failed, then we just say we failed to acquire the material and return a null pointer. Okay, so again, pretty straightforward stuff. All right, so that is our acquire from config. The next one, as you might have guessed, is our release, which again is remarkably similar to our texture system. So again, we ignore requests for a default material release, right? We go through, we get the hash table entry. If we have it, we check to see if the reference count is 0. If it is, that means that material didn't exist and that we're trying to release something that doesn't exist, and then we just return do nothing. Otherwise, we decrement the reference count. If that is now 0 and it's an auto release material, we go ahead and release it by getting a pointer to it, destroying the material, setting the handle back to invalid ID, setting auto release to false, and outputting a trace message. We also output a trace message if it is not auto released. Okay, we go ahead then and update the hash table. Okay, if for some reason one of these checks fails, we bleat about it, but there's nothing else to be done. Okay, next is load material. So this is the first of those private methods that is actually used in acquire, right? So we call that here. So this takes in our material config, however we got it, whether it was in code or whether it was loaded from a file, and a pointer to a material. We go ahead and 0 out that material. And then we go ahead and take a copy of the name from the configuration to the material name. We copy over the diffuse color. And then if the diffuse map name is, if the length of that is greater than 0, which actually, yeah. So if the string length of the diffuse map name is greater than 0, meaning it's not an empty string, then we set the use for that diffuse map to texture use map diffuse, and then we go ahead and acquire the texture from the texture system, setting that auto release to true. If for some reason the diffuse map texture is not able to be loaded, then we go ahead and throw a warning about that, saying, hey, we couldn't load this, and instead use the default texture to keep things from crashing. If for some reason we do not have a diffuse map, then we are going to set the texture use to unknown and set the texture to a null pointer. This is both technically handled by the zero memory that is done up here. However, this is just to be super explicit and clear in the code. I have a to-do here for other maps when we go ahead and add them, so they'll be done in a similar fashion like this. We might extract that out to a separate function of its own. And then we send it off to the renderer to acquire resources. So we just say renderer create material, which we have not created yet. And then if that fails, we go ahead and bleat about it and return false. Otherwise, we return true. So the renderer create material, that's coming soon. Destroy material is really simple. So all it does is spits out a trace message and then releases any texture references, right? So for each one of these maps that we have on it, we just go ahead and use the texture system to release that texture. Then we call the renderer to destroy the material. We also don't have this yet, but that releases renderer resources, so our Vulkan resources. We zero out the memory and then set all the IDs back to invalid, and that's it. Next in our private methods is creating our default material. So all we do is we zero out the memory for the default material. We set the ID and generation to invalid ID. We take a copy of default material name into material name, default material dot name rather. We set the diffuse color to white. We set the use to we set the diffuse map use to texture map texture use map diffuse. We set the texture to the default texture, and then we go ahead and call renderer create material. And of course, if that fails, we bleat about it and return false. Otherwise, we return true. Okay. Now, the next thing that we have to do is load our configuration file. And this one I'm not going to breeze through because this is actually a little bit different than what we've had to do before, because with textures, STB image actually handled that for us. In this case, we have to handle it ourselves. First, we need to kind of define what this material file looks like, okay? And so to do that, we actually are going to go ahead and create a material file under our assets folder. So under assets, I'm going to create a new folder, call it materials. Under that, we are going to create a new file, and I'm going to call it test_material.kmt, right? And KMT is Kohi material, right? And the layout of this is going to be very, very simple, right? So we have a comment up here which begins with a hash symbol or a pound symbol, and it basically says that we should just ignore whatever's on that line, okay? We have a version which we're going to set to 0.1. This will actually make a difference once we start enhancing materials, but for right now we're not going to use it. Then we have name is test material. This generally should match the name of the file, but it doesn't have to, right? And then diffuse color is where we're going to use our vector 4 from string, right? So we just set 4 floating point values for RGB and A respectively. And then the diffuse map name in this case is going to be what we're going to set to cobblestone 1. Cobblestone 1 doesn't actually exist, and that is done on purpose, and I'll show you why that is in a bit. So this is the format, right? So anything that's not a comment or a blank line is basically going to have a variable name and then an equal sign and then a value, okay? So these are all going to be the same. The order of these doesn't matter, the number of blank lines doesn't matter, as long as they're all here. And actually, technically speaking, they don't all have to be there. We can handle it without and just use some defaults, right? So bearing this in mind, let's go ahead back to our material system and write our load configuration file, okay? So the first thing that we're going to do is we are going to create a file handle, use our file system open, pass along the path of the file. We are only going to be reading. We are not going to be opening this in binary. And then we're just going to pass the address of f, right, our file handle. If for some reason we're not able to load that, we're going to bleat about it and return false to indicate failure. Next, we are basically, most of our logic is going to be within a line-by-line loop that looks something like this, okay? So we have a 512 character line buffer. That's what we're going to limit the length of our line to, is basically 512 or 511 characters with a null terminator. We are going to take a character pointer to the address of the first character in line buffer. This will basically give us a pointer that we can then pass the address of to our file system read line. Our line length is going to default to 0. Our line number is going to default to 1. This is just for reporting purposes. Okay? And so our file system read line is going to take the address of our file handle. It's going to take 511 for the max length because 512 is there for a null terminator at the end, so 511. We're going to take the address of p, which is our character pointer here, and we are going to take the address of line length so that we know how long each line is. First thing we're going to do within that line is we are going to trim the string, so we're going to use our trim string method, and that is just going to return our trimmed string. Next, we'll go ahead and get the length of the trimmed string, because that may very well be different from the actual length of the string itself. Next thing that we're going to do is we are actually going to go ahead and skip blank lines and comments, right? So we want to go off the trimmed version of the string, right? So if the first character of that is a pound symbol, that means that we are going to be ignoring that line. Likewise, if the line length is less than 1, we're going to be ignoring that line. So we'll increment the line number and continue. Okay. Next, we're going to start the process of splitting the line into a variable and a value. Okay. And we're going to do this by getting the string index of the equal symbol within the trimmed string. Okay. So this is going to be the equal index. Right here, it's going to say if the equal index comes back as -1, meaning it did not find it in a non-empty or non-comment line, then it's going to warn us that we have a potential formatting issue. And it'll actually tell us that the equal token was not found, and that is skipping the line number that is passed here. Okay? Then we'll increment the line number and keep moving. So for the variable, we're going to assume a max length of 64 characters for the variable name. So we're going to create a raw variable name character array. We're going to zero that out, take the string mid of that. So we're going to take the raw name, variable name as our destination. The trimmed string, which is the whole line, is going to be the source. We're going to start at 0, and we're going to pass it the equal index. So we're basically going to go from the beginning of the string up to the equal sign. And then we'll go ahead and trim that string to get the trimmed variable name. We're going to do the same thing for the variable value. So what we're going to do is we're going to take 511 minus 65, which is also going to account for the null terminator and the equal string. And that's going to give us 446, right? So our value can be a maximum of 446 characters long, which should be more than enough. We zero that out, we take the substring, which basically we're saying here, we want to read the trimmed string into raw value, taking the equal index, so the spot or the location of the equal symbol, +1, and then we're going to pass -1 for the length, which is basically going to say read to the end of the line, or whenever we hit the null terminator. Then we'll go ahead and trim that. Okay. And next, we're going to go ahead and process the variable. And I'm just going to paste this in and quickly explain it. So for each one of these variables, we're going to try a string equal I, and we're going to take the trimmed variable name and compare it against different things. So the first one we're going to look at is version. For now, we're not doing anything with it. The next one we're going to do is name. So if it's name, then we're going to take a string copy of the trimmed value into the out config name. And the max number of characters that can be is determined by the max material name length, which is 256. So the next one is the diffuse map name, right? So if it detects that, then it'll do the same thing with the diffuse map name from the trim value with the max length of texture, okay? The next thing is going to be the diffuse color, and if we run across that one, it's a little bit different. We actually have to parse the color. This is where we use our string to vec4, so we pass the trimmed value and we pass the address of outconfig diffuse color, and this will populate that for us. If for some reason that fails, we will go ahead and warn about it, and then default the diffuse color to white. Okay. And I'm also going to just slam a to-do in here to remind us that we have more fields that we're going to be adding to this. Okay. And then before we move on to the next iteration of this loop, because remember we're still inside of a loop, we are going to clear the line buffer and then increment the line number. Okay. And once we get to the end, we're going to go ahead and return true, right? And actually, that reminds me, we need to actually close the file too. So we'll do file system close and pass the address of f. Okay. And that will close off that file handle. Great. So that is it for loading our configuration file. It's actually pretty straightforward stuff, right? And so if we find a configuration file for our material, we'll go ahead and load that. All right. Okay, so we're getting there. We're getting pretty close, actually. All right, so one thing that we're going to want to do is in our Vulkan material shader, we're actually going to change the way that the acquire resources and release resources works. So right now we're just outputting a object ID. We actually just want to take a pointer to a material, right? So I'm just going to say material, and I'm going to do the same for release, right? And let this worry about IDs and so forth, okay? Which means here in Vulkan Material Shader C, we're now going to have a couple of errors down here. So we have our shader release resources, acquire resources rather. So we're going to change that to use material, and we'll change release to use material, okay? And since we're down here, we might as well go ahead and make the changes that we need. So instead of setting the out object ID, we're going to set the material internal ID to the object uniform buffer index. And we're going to go ahead and get rid of this object ID because we don't need that anymore. And we'll just use the material internal ID instead to get the object state. Okay, so that should be it for that. Again, we need to make a small adjustment here for release. So all we need to do here is just use the material internal ID here to get the object state for that. And just for the sake of having proper naming, I'm actually going to rename this to instance state. Okay. And one more thing that we're going to do is here we're just going to set the internal ID to invalid ID, right? And that should be it for our acquire and release. So a couple of other changes that we need to make while we're in this file is, so way up here where we are defining our descriptors for our local object descriptors specifically, right above this, we just want to go ahead and put in our sampler uses, which right now, if you recall, is only an array of 1 because we only have one sampler. And we just want to set that first sampler to use the diffuse map, okay? So this just fills that out so that we can use that. That means that we don't need this local sampler count anymore. And instead, for our descriptor count here, we'll use the Vulkan Material Shader sampler count, okay? One other thing that I actually somehow missed is when we're creating our object pool, we need to set the VK descriptor pool create free descriptor set bit. This allows us to actually explicitly call free on descriptor sets that we want to free for later allocation. I suspect that we weren't actually hitting this before because we weren't actually releasing materials, but now that we're going to be releasing materials, we actually need to have that set. So need to go ahead and add that. Okay, and there is one actual update that we need to make to our update object, right? But in order to actually do that, we have to do another step first. So we actually need to modify this geometry render data. And right now we're just passing an array of textures, which is kind of crappy, right? So what we actually need to do here is we need to pass our material, or a pointer to our material. Okay. And since we have that, we no longer need this object ID, right? Because the material has our internal ID. So we'll change our structure to look like that, which is much simpler. Which means that we need to go back into our material shader. And where we update the object, whoops. So where we update the object, now we have a couple places with this object ID that is now wrong. So all we need to do is change that to material internal ID, okay? And that's going to use that internal ID instead of having a yet another separate object ID, okay? One more thing I want to get rid of is actually this this diffuse color fading back and forth. We'll go ahead and keep that commented for right now. But now that we actually have a material, let's go ahead and kill that and instead use the diffuse color that is in the material, okay? One other thing that I would like to do is this code here that checks our generations, we're actually referencing this more than once, so I'm actually going to change this to a pointer. So we're going to get a pointer to our object state, descriptor states, descriptor index, generations, image index, right? So it's basically all this stuff right here. So I can just say the dereferenced global UBO generation and compare that against invalid ID, okay? Likewise, that means down here, I can also just set that pointer, okay? However, instead of just setting it to 1, we really should set it to data.material.generation, okay? And along with this, we should probably also be checking to make sure that not only that we have a valid ID, but also that the generation hasn't changed, right? Because we introduced the concept of being able to change the generation if something dramatic on the material changed. And so if the generation of that changes and is not equal, it can also trigger this, okay? Next, we're going to come down here and finally address this to-do here. And actually, I'm going to get rid of this to-do because this actually does work, and that's done. So before we actually even get a texture, right, the first thing that we're going to do is get the texture use. And this is going to look at the shader sampler uses, sampler index, right? And so this was where we set that above the first index to be a diffuse map. Now we have a use for that, right? And we'll come back to that in a second. The next thing that we're going to do is we're going to default this texture to a null pointer, okay? And then before we even get the descriptor generation or descriptor ID, we're going to switch on that use, right? So if the use is texture map diffuse, then we're going to set that equal to the data.material diffuse map texture, right? Otherwise, we're just going to throw a fatal error, meaning we actually don't know what it's supposed to be used for, and we have a sampler we don't know what to do with, right? So this gets rid of us not having to. So this gets rid of us not being able to determine what use the texture has, right? So I'm going to get rid of this to do. Okay. And then all the rest of this pretty much works as normal. Okay, so I think that is actually everything that we need to do in the Vulkan material shader. So the renderer front end has some errors in it that we need to fix. So that is mostly here with our renderer draw frame. So now we have our data object ID equals 0. We don't need that anymore because we have the material, right? So we need data.material, right? But we don't actually have any material loaded yet here, right? And so that is actually the next thing that we need to do. So let's go up here to our state, right? Because we have this test diffuse texture here, and we really should be using a material at this point. So I'm going to change this to material. It's a material pointer. I'm going to call it test material. Material. Okay. And this is still to do temporary code, but at least now we have our test material here instead of using a texture directly. Okay. So instead of just acquiring a new texture, we are actually going to acquire the texture for the test material, right? And we're going to use the default diffuse map.texture. And again, we're going to call texture system require just like we did before. And if for some reason that does not load, we're going to warn about it, and we're going to go ahead and use the default texture. Okay. Now that we've done that, we can come back down to where our errors are and change the way that this works. So I'm actually going to take this section of code here and get rid of it and replace it with this. And this is basically going to say we're going to create a default material if it does not exist. Okay. And so what we're looking at here is whenever we draw the frame, we're going to make sure that the test material exists. And if it does not exist, then we're going to go ahead and try to acquire it. If the acquisition fails, then we're going to go ahead and set up a manual configuration, passing in a name for test material, setting auto release to false, default diffuse color, the default texture name, and then we're going to go ahead and acquire the material from the configuration, right? So we set up a configuration and acquire it manually, right? Now we don't have material config here, so I'm guessing that means we're actually missing an include at the top. And we are, so we need to include systems material system.h. Okay, that clears up some of it. So now that we have this, instead of data texture 0 equals state pointer test diffuse, we are actually going to use the material now. So we're going to set data.material is equal to state pointer test material. Okay, and again, this part is still very, very temporary, but you can see how we're able to tie in a lot of our stuff here. And actually I've got some temporary code up here. Let me just get rid of that. Okay, so we set the model, we set the material, and then we go ahead and call our update object. Okay. Now, we have done our create texture and our destroy texture, but we have not actually done a create material and destroy material, which are called from the material system. So we need to actually go ahead and set that up. So we're going to go head over to render frontend.h and plug this in, right? This is just going to be render create material, render destroy material. Now we can head back to the C file for the front end, and at the bottom we're just going to pass these through to the back end. The back end does not have this either. So we need to create the create material and destroy material for the back end. So to do that, we're going to go to renderer types, INO, and to our renderer backend structure, we're just going to add two more function pointers, one to create material, one to destroy material, which means that our Vulkan backend also needs to have these. So we'll go to our Vulkan backend, oops, and create our Vulkan renderer create material, Vulkan renderer destroy material, passing our material pointer. Next, we'll go to the bottom of the C file, and I'll just paste in our create material. All this does is check to make sure that material passed in exists, acquires our shader resources for us. If it fails for some reason, it bleats about it and returns false to indicate failure. Otherwise, it says material created in a trace message and returns true. If for some reason material does not exist, it bleats about it and then returns false. The destroy material basically just undoes that. So if the material exists and its internal ID is not invalid ID, then it goes ahead and releases the shader resources. Otherwise it says Vulkan shader destroy material called with internal ID equals invalid ID, meaning there's nothing to be done. If material doesn't exist, it bleats about it and does nothing. Okay. So that is it from that perspective. Last, we need to actually hook up these new methods. So we need to go to renderer backend.c, and we need to hook up our two new function pointers. So here's create and destroy. Likewise, we need to come down to backend destroy and zero them out. And I believe we have done most of the work to actually set up our material system. The only thing we need to do left is actually hook it up to our application. So we'll go here to the top and we'll include the material system. We'll also go ahead and add our material system memory requirement and a void pointer for our material system state block. Right after we go ahead and create or stand up our texture system, we'll stand up our material system. So this is almost exactly the same as our texture system. The only difference is we're only going to allow 4096 materials. Again, this is configurable. We can tweak it later as need be. This is just what we're going to roll with for right now. Okay, so it goes ahead and allocates the memory for that, and then tries to do the initialization. And if it fails for any reason, it bleats about it and returns false to indicate failure. Of course, since we have the initialize, that means we also need the shutdown, which comes after our game loop, right before our texture system shutdown. Okay, and so we just call shutdown on that. One more thing that I just remembered that we actually need to do is in the Vulkan backend, towards the top, right around line 270 or so, we actually are actually requiring shader resources and just saving it off and throwing it away. This actually can go away because we're actually handling this properly using materials now, so that is no longer needed. Last but not least, there is one more change that I want to make in renderer types, and this is just a naming change. So we have our object, uniform object. That's also kind of a crappy name. So I'm going to call this material uniform object because that's really what it is. Okay, so we're just going to save all, and I'm going to go ahead and build. Hopefully we didn't miss anything. Okay, and just to be safe, I'm going to go ahead and run my post build, which should go ahead and copy over all of our assets, right? And I'm going to go ahead and run. And looks like we got some errors, so that is definitely not cool. What did we miss? So, looks like offset of 64 is greater than or equal to VK buffer of the size of 64. That makes me wonder if I just need to clean and rebuild, so let me go ahead and do that real quick. Run again, and it looks like we're still getting that error message. Let me see. So it looks like our logic is working fine. I'm not 100% sure. I'm going to figure this out off camera. Okay. So the issue was our internal material ID, in this case, was 1. And so our offset wound up being 64. However, if you recall in a previous video, when we actually set up the shader, right around line 180 or so, when we actually create the Vulkan buffer, we had basically this there, right? And this should really be times the total number of materials that can exist, right? So that we have one uniform object available per material. And since we were loading more than one material, we were overflowing this buffer and it was failing. So that is the fix for that. Anyway, we'll go ahead and build this real quick. And we'll run. And we can see that we have our default material, right? And if we actually look at our logs, we see here load texture failed, assets textures, cobblestone 1. So remember I put cobblestone 1 in the material file, can't fopen. So it says it failed to load the texture using the default texture instead, which is exactly what it did. So if I flip through this by hitting T, we can see that our texture switching still works, and we're getting all the messages as expected. And when I go ahead and quit the application, we see here that we destroy our test material, and then we release the texture for that, and then we destroy the default material. Okay, and so everything is working as designed. One last test we'll go ahead and do is we'll go ahead and fix our material file, and I'm going to choose a different one here. Let's look at our textures. Let's go with paving 2. Actually, let's just go with paving, right? And I'll just do a post build and run. And now we can see without hitting anything that we get that texture loaded. We see here that paving does not exist, material created, textures loaded, and now we're good to go. So anyways, that's going to do it for this video. Thank you guys so much for watching. If you liked the video, please give it a thumbs up. If you haven't already, consider subscribing. Click the little bell icon there to get notifications as to when new videos in this or other series drops. And I'll see you guys next time.